Hi, my name is Vidya Rimal. Today I'm gonna give a short project demo of our information retrieval assignment. Let me open my code. This is a README file that I've created so that it'll be easier for anyone to run this code. Our task was divided into two parts. One was a vertical search engine, and another was a document classifier. I've created a virtual environment so that everything will be easier for me. Let me just activate the virtual environment. The virtual environment is activated. Let me just install all the dependencies. With the vertical search engine, what we're trying to do is we're trying to mimic Google Scholar, but the domain is very restricted. In a way, we're only focusing on one domain, that is, we're making sure that all the output of our results of our search engine, the one of the author has to belong to um, this department of computational science and mathematical modeling. So this is the site that we're going to crawl. We're going to extract data from this. The data that we primarily need is publication title, publication link, publication date, and then author's link as well. Anyways, author link as well, and they have to, one of the authors has to be from this department. I guess all my dependencies are done. Before we see how the search engine works, let's look at the code. This is the scraper file that I've created. We're using Playwright and Beautiful Soup for this extraction. Oh, this is the code. Playwright. Also, we are using stealth mode so that we can escape the bot identification and everything. Uh, and what else? Yeah, so the data that we extract from this uh, scraper is stored in a JSON file. We have of about research publication JSON file. We have of our 961 data here, and this scraper is scheduled to run weekly Sunday at midnight, so that the data is up to date and this file is updated every week. And after this scraping is done, we move to indexing. For indexing, we're using skitlearn to implement TF-IDF vectorization. But before this, we also do pre-processing, where we the data that is in the JSON file, we pre-process it, we tokenize, we remove stop words, and stemming is also done. And then inverted index is created so that it'll be very easier for our search engine to extract data and give it to the user that matches the query. So yeah, that is done. Also, we use cosine similarity. You can see the code here to calculate a relevancy of our output with the user's query. User query is also pre-processed. We use the, oh, let me show you the code as well for processing. Where is it? Oh yeah, this is the code. We process query as well, so that same thing is done where tokenized stop words are removed and stemming is done, so that um, it'll be easier for our search engine to match with the inverted index that we have created, vectorization that we have done. I have talked enough, almost about 5 minutes of what we have done, but let's see what it actually looks like. Let's go inside the search engine and run the server and go to our search engine. Okay, this is the link of our search engine. This is what the search engine looks like. It's very simple. Let's try one of these keywords that I've already used. Let's try computing. Okay, these are the results that we have. um uh, like I said before, publication date, publication link, that will take us to the site there, authors, and also relevance score that we have calculated using cosine similarity. This is also the link, and this is the author. This is the author. ECS Schools of Science. Yeah, so this is the output. Let's look at another author. They belong to Center for Computational Science and Mathematical Modeling. These are the data. We can also go to this publication, this research paper, and we have about 5 pages of output here. Let's try something else. Let's try uh, okay, let's try novel algorithm for classification. Oh wait, I cannot copy this. Oh, I can. Classification, let's try this. It's already 6 minutes. I have to talk about classification as well. Okay, so you can see the relevance score, and yeah, these are the outputs that we have. It's very simple, but every information is provided. The publication date is here. Now for classification, this is the link for document classification. I have uh, news.csv. This is the file that I've created. I've extracted all these title from all these summaries, not title, from different news sources. We have 3 categories: entertainment, politics, and economics. And of about how much data do we have? 776 data that we have. And for this, we use naive-based algorithm to classify document. That is the most suitable for text classification. And for this as well, pre-processing is done, tokenization, removal of stop words. But for this we are doing stemming instead. We are doing lemmatization. I hope I'm pronouncing that right, instead of stemming, because we want to keep the semantics of the data as it is, because semantics matter when it comes to classifying the document. Also, lazy initialization is done to train the model. When we first search the query, we're using 80 to 20 split data for this, for to train the model. And also accuracy, precision, recall is also calculated to see how accurate our model is. We also have confusion matrix generated, so that we can see how our model confuses one category with another. um, yeah, did I miss out on anything? So yeah, this is our classification code. Let's go to the classification site and see if it works. Wall Street search, no, not search, classification. You can see the accuracy, precision, recall is here. Confusion matrix, to see how our model confuses one category with another. Let's try something else. What do we try? NATO, let's try. Maybe NATO is politics. For entertainment, Netflix. So what is one Netflix movie that we have? I don't know. Netflix. Cars, maybe. Cars is that movie on Netflix? I don't know, but Netflix is entertainment, I guess it is. So this is how the document classification works. Thank you so much.